video.
So I'm sure you could tell that video that you just watched was not a typical video. Instead of having RGB pixels like you normally expect, it was made completely with ASCII characters. This was done with some Python code I wrote that takes in a normal video and then performs matrix convolution with ASCII characters to create that sort of picture that you just saw. It was really fun to write. I wrote it about 6 months ago when I took an 8-month break from programming when I was working in sales. I wanted something to kind of get back into programming, brush up on my Python skills. Well, it's a pretty small project. It's under 250 lines. I thought I'd run through it with you guys, explain some of the algorithms, explain kind of what I was thinking when I made it, and hopefully you'll get a better understanding of Python and also matrix convolution. So here's all the code I wrote for this algorithm. It's about, let's see how many lines it is. It's 211 lines. I started this project by mainly focusing on pictures, and then after I made the algorithm work on pictures, I figured videos are pretty much just pictures playing at 30 frames per second. So at the top here we have all the libraries I'm using. OpenCV is what I use for the video. Multiprocessing is what I use to speed up the video processing. NumPy, typical, OS, typical. Pill is a really great image processing library. It's what I use for any sort of enhancements or pre-processing I have to do on the image. Sys, typical, and then TensorFlow is probably the most important library I use in here. Before I did this project, I did a lot of machine learning stuff with TensorFlow, which is actually what gave me the idea for this project, because the way that convolutional neural nets work is really similar to the way that this algorithm works, but TensorFlow really important. And then time, just to time how fast everything's going, and threading so that when I process the video, I can do it on multiple threads, kind of speed it up. So at the top here, we set the number of threads. We have our font box size. I'll get to that in a second. And then we have image height, image width. This is because on different monitors, there will be different number of characters you can put on the screen. I always try to put this at the max for whatever monitor I'm working with, just because I want it to be as big as possible, because then you'll get the best resolution. And then here, used characters. These are all the characters that we use to create the image. It's actually not all the characters in ASCII, and that's on purpose. I found that for some reason, removing the capitals and removing some of the symbols just made things turn out better. Don't ask me why. It was much more of an artistic choice than a scientific choice, but I did it. It looked better, so I kept it. So at the top here, then we just have some typical functions to get the file, get the image from the file path. And then we have a function here to get the image dimensions. So this function is really important. This is our pre-processing function right here. The first thing we do is we convert it to grayscale. This is important because the RGB values really don't mean much. ASCII, there's going to be no color anyways. So we convert it to grayscale. We also enhance the contrast. We enhance the sharpness. This also just helps things come out better when we do our convolution. We resize the image right here. And then we also subtract the mean of the image times a brightness modifier. Now, again, a lot of making this turn out good was kind of futzing with it, playing with different values. And I knew that I would want to center the pixels around 0, right? So that pixels more bright than your average pixel are above 0, and the ones less bright than your average pixel are below 0. But I also found out that it kind of turns out better if you almost have them centered around a negative value. So like negative 1.5, 1.85 seem to work the best. So that's what the brightness modifier is, right? We multiply the mean by 1 over that brightness modifier, and then we get the pixels centered around a sort of slightly negative number. Okay, so this function right here is really important too. This creates our matrices for the characters. You can think of them like a matrix where the values that have a pixel are 1, and then the values that don't have a pixel are -1. I originally tried doing 1 and 0, but 1 and -1 worked a lot better to actually create accurate pictures. So with Pill, we create a new image that's dimensions are font box size by font box size. We create a draw with Pill that's going to allow us to draw our character on that image. We then, at position 3, -4, which is a little offset, right, so that we have that character centered inside of our image, we draw our character as text into the image. We then turn it into a NumPy array, and we fill anywhere where it's 0 with -1, And this is just a little edge case for the underscore character. I think for some reason the underscore was being drawn as all zeros, so I just changed that here. And then we have this function here that pretty much gets us a matrix filter with every single character in it that we can then convolve over the whole image, get the scores of how each character best fit each little square in the image, and then later draw the image with those scores. Right? So now let's get into the meat and potatoes of the algorithm, right? What is matrix convolution, kind of how this whole thing works. So to sum up how matrix convolution works, imagine that you have one matrix here. We'll call this the video, right? So this is the little tile of the video right here. And then on top of that matrix, you're putting our filter, right? And what you're going to do when you do that is you're going to first multiply each value in the filter by the value beneath it in the picture. Usually you start at the topmost corner, right? You're going to take that value, you're going to multiply it by the value beneath it. Once you do that, you're going to have a bunch of values that's going to be equal to the size of your filter, right? You'll have that many values. You then summate those values, and the corresponding value you get is a measure of how similar the filter is to whatever it's on top of. Now, how does this work? Let's use a really simple example that involves ASCII characters like we're doing, right? So in our picture, we center the values around -1.8 about, and in our character matrix, the values are either 1 or -1. So what's going to happen is that if we have a portion of our picture that's very dark, what will happen is that that's going to mean a lot of negative values. Negative values in the picture will then be multiplied by negative values in our character filter. What happens when negative values are multiplied by negative values is that you get positive numbers, right? So when we convolve that portion of the picture that's very dark with a character that's very empty, we're going to get a very high value. If we were to convolve that with a character value that's very filled, like hashtag, we're going to get negative values. Because what happens when you multiply negative numbers by positive numbers? You get negative numbers, which will then bring down that similarity score, right? So to reiterate, if we have a picture that has a lot of negative values and we convolve it with a filter that has a lot of negative values, we'll get a very high similarity score, right? In this example, dark picture, empty character. Where if we have a very bright portion of the picture that has a lot of positive values, when we convolve it with a character that has a lot of filled in pixels as well, which remember are positive values, we'll get a much higher similarity score. And that's kind of how the convolution algorithm works to pick the best character for that portion of the picture. Let's get the function that actually does the convolution, right? So of course, anytime you're doing TensorFlow, like I say this with my full heart, anytime you're using TensorFlow, you will just have to write the code, have it throw an invalid shape error at you, and then just use NP reshape until things work. Again, I wrote this code a little bit ago, so I cannot remember the exact shape that it wanted, but again, we do a couple NP reshapes here just to make sure that it's the proper shape for everything. Right after those two reshapes, we perform the convolution with TensorFlow. Great machine learning library. They have this function here, tf.nn convolution, and what we do is we pass it the image array, right, which is that pre-processed NumPy array for the image, and then we pass it all the filters. Now, I know in the previous example, I spoke about convolution in terms of a single filter, but what we're actually able to do here is overlap all of our filters in a three-dimensional array, and then run that three-dimensional array over the image so that we get scores for every single character in that three-dimensional array, which we can then use to draw our image, right? So we do that, and a really, really, really important thing here is setting the strides to be font box size. Why do we do this? Well, normally when you do convolution, if you have a matrix that's, let's say, 20 by 20, and you're running over a 100 by 100 matrix, you will typically move 1 for each time that you move the filter. We don't want to do that here. Why don't we want to do that here? We only want to move by our font box size. We only care about the score where we're specifically going to put that character. We don't care about the space in between a character. That means nothing to us. we only care about this character here. What's the best character? And then we move over to another character. What's the best character here? And then we move over to another character. So that's really important. We're moving by the size of the font box each time. And then what we do is we perform an MP argmax on our resulting convolution matrix, which is just pretty much going to get us what's the strongest one, what is the indice of our used characters array that is the strongest for our specific spot in that resulting big old convolution matrix, which then, tells us which character we should put there. I mean, these are all a lot of higher level functions down here. So genImage, this actually draws the image. What we do is we get our best letter indices from the get convolution score. We then zero index it because it's going to have one extra dimension. And then for each row in our best letter indices, because best letter indices, you can think of it almost like having the same structure as the picture. Instead of having the ASCII characters, though, it just has the index for which ASCII character we're going to use in our used characters array. So this kind of just takes it from, instead of being the indice, it's going to actually be the ASCII character. And instead of being a matrix, it's going to be a really big string where the rows are separated by new lines, which kind of creates that picture size box. So that's all the code you need to create the images, right? I mean, coming in at about 100 lines too, if we include the main function that you need. So the last portion of the code I wrote just helps it deal with videos. I figured if you can do it with pictures, do it with videos. And pretty much all we have to do with the videos is just split the videos from being videos into just the individual frames. We then set up some workers that each take a portion of the video, pre-process it, and then the really cool part, and also the hard part to figure out, is playing the video, right? So this function here is actually probably the most interesting part of the video stuff. Actually playing the video in the terminal was kind of tough to figure out. One, because, you can put up the frame, that's pretty easy. Deleting the frame and then putting the next frame was a little harder. What I ended up doing was using this escape sequence right here, that when you print it into the terminal, it's pretty much the same as hitting Command K. So clear the terminal. So in order to play the video, what we first do is we calculate the milliseconds per frame, right? 1,000 divided by 30, because we're playing at 30 frames per second. We then generate a list of timings, which is going to be the time that frame plays, right? And then what we kind of do is for each frame in the video matrix, we just kind of wait until it's time to play that frame. If it's currently time, we clear the picture, right? So whatever the last frame was, we take it out of the terminal. We then put the next frame. We then advance the frame number by 1. The main meat and potatoes of this was turning it from ASCII to picture. And then once you had that, the video was pretty easy. Videos definitely take way longer than images because it's like 1,000, 10,000 times the work, depending on the length of your video. But yeah, I thought I'd go over this with you guys. It was a really fun project to do. I'm going to link the GitHub in the description if you want to download it, play around with it. This is definitely one of my favorite projects I've done. But yeah, that's pretty much it. This is the video. I'm posting a video every day until I get a job in software engineering. Kind of just a fun thing for me to do. Usually my videos are on different stuff or stories, but I thought I'd try one showing my code. Also, if you were looking for a software engineering job yourself, try out my plugin Applicant IQ. It'll give you an AI score on how your resume fits any job on LinkedIn, any job on Indeed. I love using it because there's nothing worse than filling out a job application for a job that you don't get. So for me, it helps me kind of like find those jobs that I'm most qualified for and I have the best chance of actually getting an interview. So link will be in the description for that too. But for now, I hope you learned something and take care.